Let's start our chemistry class, and if you can recollect what we have done in the last class, we have taken ionic compounds and their arrangement. We have taken with coordination number 6 for NaCl, coordination number 8 for cesium chloride. Can you tell me, Alti, what is that we have taken for coordination number 4? With same coordination number for cation and anion, and then with different coordination numbers. We have taken ionic lattices of NaCl, cesium chloride, zinc sulfide, calcium fluoride, fluoride structure, Na2O. For these 4, we have taken examples with coordination number 4, but here it was 8:4. Here it was 4:8, here it was 4:4, and for this the coordination number was 8, for this the coordination number was 6. We did that yesterday. In the ionic compounds பார்த்திருக்கோம் NaCl, cesium chloride, zinc sulfide, calcium fluoride, which we call it as fluoride structure. In the structure oda name enna எடுத்திருக்கோம் anti-fluoride structure. Zinc sulfide structure oda நம்ம video பார்த்திருக்கோம், the way it has been arranged. Can you recollect? Fine, let's go with the defects. Today we are going to talk about the defects. Normal crystal structure length, in case if an ion is missing or if it occupies some other place, it results in what is called as a defective structure. So let's go with crystal defects. So defects வந்து நம்ம என்ன, what is other term that we use, இன்னொரு term என்ன யூஸ் பண்ணுவோம், imperfections. Imperfections என்ன நம்மளுக்கு perfectா இருக்காது, so we call that as an imperfection. இதுல வந்து atomic defects இருக்கலாம், இல்லைன்னா electronic defects. As the name indicates, there will be a difference in So let's go on with the topic. Shall we do with the topic? Fine. Atomic defects and எப்போ சொல்வோம் நம்ம, atomல வந்து no variation இருந்தா we'll call it as atomic defect. இல்ல electronsல வந்து நம்மளுக்கு variation வந்தா we'll call it as electronic defects. So atomic defects la வந்து நமக்கு it can be a defect at one particular point. எங்காவது ஒரு பாயிண்ட்ல டிஃபெக்ட் இருக்கலாம், இல்லைன்னா கிறிஸ்டல் லாட்டிஸ் எடுத்தா it might be in one single line. லைன்ல டிஃபெக்ட் இருந்தா what do we call it as a line defect. Stoichiometric defects இருக்கலாம், point defects ல impurity defects, non-stoichiometric defect. What do we mean by a stoichiometric defect னா என்ன? டிஃபெக்ட் இருந்தாலும் நமக்கு ஃபார்முலா வந்து அப்படியே இருக்கும். Formula will be the same, like if their ions are missing, like one of the sodium and chloride ion are missing, the ratio if still remains as 1:1, we call it as a stoichiometric defect. Number defect irundhalum formula same irundha adu vandu stoichiometric defect nu solluvom. Non stoichiometric defect eppo solvanga, defect irundha நம்ம formula vandu same ah irukka, like if I take iron oxide formula, what do we write? FeO. Defective structure la enna irundhom Fe 0.93O. The ratio vandu change agudhu. Like let me take nickel oxide 0.96O. We don't write this formula in a normal structure. So formula la vandu namu konjam change ah irundha, if it is not as per the formula, the number of atoms are not as per the general formula that we take it up, அது வந்து நம்ம non stoichiometric defect ன்னு சொல்லலாம். Non stoichiometric defect வந்து நம்மளுக்கு metal deficiency defect ஆ இருக்கலாம், இல்ல metal excess defect ஆலும் இருக்கலாம். So let's take one by one. Stoichiometric defects வந்து ரொம்ப important நம்மளுக்கு exam point of view. Schottky and Frenkel defect உங்களுக்கு board examலயும் கேட்கலாம், இல்லனாலும் objective exams, that is உங்க NEET examலயும் importance கொடுப்பாங்க Schottky and Frenkel defects. Along with this, what we have done in density and yesterday's topics are equally important for your competitive exams. First வந்து textbook நல்லா படிக்கணும், NCERT textbook. Then you try to solve as many questions as possible till you get confidence. So let's take So there are point defects that do not disturb the stoichiometry of the solid. அது என்ன சொல்வாங்க? Vacancy defect. So if you can see the crystal structure here, there are some white patches shown. So என்ன ஆகுதுங்க? There is a vacancy in this particular positions. Vacancy இருந்தாலும் நம்மளுக்கு formula வந்து change வரல. When some of the lattice sites are vacant, the crystal is said to have a vacancy defect. This results in decrease in density. Density எதனால கம்மியா இருக்கும்? Because the volume, empty space is becoming more. நமக்கு என்ன ஆகும்? Density வந்து கம்மியா இருக்கும். So when will we get this? These defects might happen when you either heat the substance or when you are cooling it, if you are not doing it properly. The defects vandu varlam. Vacancy defect, as the name indicates, there might be vacancy at certain lattice points. So vacancies nala enna agudhu namalku, we are having a lot of empty volume. Volume vandu jaasti agudhu. Mass is also becoming less because some of them is volume of what volume is increased? Empty void space vandu namakku increase agudhu. Because of loss of these ions, mass வந்து கம்மியாகுது. எதனால கம்மியாகுது? ஏன்னா some of the ions are missing, so mass will also become less. Interstitial defect, as the name indicates, it moves away from that place and occupies some void space. It moves away from its and then occupies some other space, then you call it as an interstitial defect. You take a very simple example, like let me say, when your friend is sitting in your classroom, you are sitting somewhere else, the moment you find somebody very close to you. You go and sit in that place. Your place is vacant and you're sitting in some other vacant place. So interstitial defect la enna agona, what happens is it moves away from its place and then occupies some other place. So if when some constituent particle or atoms or molecules occupies an interstitial site, if a foreign body இல்லைன்னா ஏதாவது extra atom வந்து interstitial site la if it occupies, then what will happen to the density of that substance will increase. Instead, if the same ion is moving, some of the ion is moving from its place and occupying the interstitial site, then the density will remain the same. There are two conditions here I said. One is when an extra atom occupies the interstitial site, ennaagum density increase agum. The same atom is moving from its place, and the place la irundhu move aagi innor place la if it occupies, what happens? The density will remain same. Am I clear? Shall I continue? Ma puriyarda? நம்ம அடுத்த ஸ்லைட் போலாமா? ஓகே. Stoichiometry defects la அங்க பார்த்திருக்கோம். First tabular column la we have two defects. One is Frenkel, the other one was the Schottky defect. We have Schottky and Frenkel defects. So when do you say it as Frenkel defect? In the compounds, where do we find them? It's in ionic solids la நம்ம பார்க்கும். Frenkel defects வந்து ionic solids la இருக்கும். When this ion cation is small and it's dislocated from its place. If you can see this, the positive ion is missing here. And it is occupying in the place la vandu occupy pandu. Can you see that, ma? It's moving from this place and occupying somewhere. I mean, I've just shown one of the cation moving from its space. What can the other name be? ஒரு பிளேஸ்ல இருந்து இன்னொரு பிளேஸ் போனா என்ன சொல்வோம்? Dislocation. So Frenkel defect வந்து நம்ம dislocation defect ஆவும் சொல்லலாம். Or what is happening? It's creating a vacancy in its original place. So vacancy defect ஆவும் சொல்லலாம். Because it's occupying an interstitial site, dislocation defect இல்லைன்னா interstitial defect சொல்லலாம். So what will happen to the density in this case, you tell me? What can happen to the density? Will it remain same? Will it decrease or increase? Density enna avuma? What will happen to the density in this case? Density will remain the same. Why will the density remain same? Enna mass வந்து அப்படியே இருக்கு. What is happening? It's moving from its place and going to some other place. It's only changing the place. Place மட்டும் change ஆகுது. Density வந்து நமக்கு we will have density will remain same. எதனால density same ஆ இருக்கு? இந்த பிளேஸ்ல இருந்து it's going to some other place. So mass increase ஆகாது. It will not increase. Why will it increase? That's what I took two examples when I was telling you this one. When will it increase, Aditi, is when an extra atom is added. It changes its position only. What is happening to the mass? How do we calculate density? Density is mass by volume. Volume வந்து அப்படியே இருக்கு. We are not changing the volume. And mass வந்து என்ன ஆகுது? If it is going away from this particular crystal lattice, volume வந்து நமக்கு empty space இருக்கு. It's only changing place, Aditi, but the mass is remaining the same. Take a classroom with the students. You are changing your place from one place to the other place. Do you think the mass is changing? But density will remain the same when a lattice point is moving from its crystal lattice to some other crystal lattice. So in Frenkel effect, what is happening? One of the lattice points, generally a smaller ion, which is a smaller ion, the cation is smaller. It moves from its place to some other place. As I said, Frenkel defect is also called as a dislocation defect. So, which type of compound show Frenkel defect is those which have a difference in the sizes of the ions. When cation is smaller than that of the anion, you can take zinc sulfide, silver bromide, silver chloride and AgI. Remember these examples. You remember this also because there are questions asked which is an ionic compound or which is a compound which shows both Frenkel and Schottky defect. When we see Schottky defect, I will go for it. You will understand why I asked you to remember this. So Frenkel defect was a dislocation defect or an interstitial defect creating a vacancy at one position, so we can also call it as a vacancy defect. Density is remaining the same. Which ion is moving is cation is moving. Cation, generally a smaller ion, moves from its position and occupies the void space. Let's take Schottky defect. It's a purely vacancy defect. Frenkel defect on the vacancy and we cannot see. We will more use it as a dislocation defect. இது வந்து vacancy and எதுக்கு நீங்க பார்த்தாங்க இந்த diagramல you can see many empty spaces. At least I can see there are 4 empty spaces. We will have equal number of cations and anions missing from their place. Equal number of cation. இங்க வந்து நமக்கு negative charge இல்ல, இங்க positive charge இல்ல. இங்க வந்து because it should be alternate, I am giving up the charges directly. இங்க வந்து negative charge இல்ல, இங்க வந்து positive. இந்த diagramல நமக்கு எவ்வளவு positive and எவ்வளவு negative இல்ல? Positive 2 are missing, negative 2 are missing. 2 positive ions and 2 negative ions are missing from their state. So what will happen to the formula of the compound? Okay, I forgot about talking about the formula in Frenkel defect. Frenkel defect la formula வந்து ஏதாவது change ஆகுமாமா? Will there be any change in the formula? If you go for Frenkel defect, ஏதாவது formula la change வருமா? அப்படியே இருக்குமா? It's only changing its position. The number of cations and anions are same. So Frenkel defect la formula same ah irukum. So it will be a stoichiometric defect. The same in Schottky defect use equal number of cations and anions miss ஆறதுனால நம்மளுக்கு the formula will remain same. So whether it is a Schottky or a Frenkel defect, we call them as stoichiometric defect. Why do we call them as stoichiometric defect? Because there is no change in the formula. It will remain the same. Very good. Schottky defect is shown by ionic substance in which cation and anion are almost of similar sizes. NaCl, KCl, cesium chloride. Frenkel defect lo in the example வந்திருக்கு நமக்கு AgBr. இதுலயும் இருக்கு. So AgBr is one example which will show both Frenkel and Schottky defect. இது difference-உம் கேட்கலாமா உங்களுக்கு examsல? Okay, tell me about the density here. Maithili density என்ன ஆகுமா? Neelambari or Maithili or anyone. What happens to density in Schottky defect என்ன ஆகும்? I think how many ions, the ions are missing, they are not occupying any other position, they are going away from it. Mass is becoming low, volume is as such. In the volume வந்து அப்படியே இருக்கு, mass என்ன ஆகுது, கம்மியாகுது. Why is it becoming less? There are so many ions that are missing. So what will happen to density in Schottky defect? Density வந்து it will become low. Good. Density will decrease in Schottky. It will remain same in Frenkel. Frenkel la வந்து நமக்கு density will be same. Schottky defect la நமக்கு கம்மியாகும். Fine. Schottky defect வந்து due to loss of equal number of cations and anions missing from their lattice size. So இது vacancy defect ஆ சொல்லலாம். Schottky வந்து vacancy defect. While here it's a dislocation of ions, so dislocation defect ஆவும் சொல்லலாம், interstitial defect. Dislocation, place change ஆனா இல்ல interstitial defect. This results in Schottky results in decrease in defect density, while there is no effect on the density of defect if it shows Frenkel. Here it is found when the ionic compounds have high coordination number. High coordination number na sodium chloride la coordination number வந்து 6, இங்க coordination number வந்து நமக்கு 8 ஆ இருக்கு. Zinc sulfide la பார்த்தா coordination number is only 4. So lower coordination number defects generally are seen in this type of defect. Number common example வந்து AGBR. Fine. Shall we go to next slide? Impurity defects. So, for molten sodium chloride, if we have any strontium chloride during crystallization, in case if there is some defect, some impurity added, what happens? Here you can see strontium ion occupying the places of the sodium ions. One strontium ion, because it has a charge of 2+, one strontium ion is equal to 2 sodium ions when I compare it with the charge. So, அப்ப என்ன ஆகும், ஒரு strontium ion போதும் நமக்கு 2 sodium ions instead of 2 sodium ions. So, one of the site will become vacant. One strontium ion, because it has a di-positive charge, it replaces 2 sodium ions. So 2 sodium ions replace பண்றதுப்போ என்னவாகும், ஒரு place மட்டும் போதும் strontium ion, the other place will become vacant. So each strontium ion replaces 2 sodium ions. It occupies the site of one of the ion and other site remains vacant. The cationic vacancies thus produced are equal to number of that strontium ion. What do we understand? If one strontium ion is added, one cationic vacancy is created. If 2 strontium ions are added, it results in 2 cationic vacancies. Are you able to understand how we are getting a vacancy one? ஒரு strontium ion add பண்ணா ஒரு vacancy வரும். In case if we are adding 2 strontium ions, we will have 2 vacancies. If we take a di-positive charge, அதே monopositive charge ion add பண்ணா we will not have any vacancies. So இது வந்து impurity defect. Impurity defect and why are we saying it? Because the sodium ions are replaced by the strontium ion. They ask you the number of cation vacancies. non-stoichiometric defects formula வந்து நமக்கு retain ஆகாது. Metal excess defect due to anionic vacancies. What do we understand from here? If any of the anion is missing, we have excess of cations. Then we call it as metal excess defect. Halides of alkali metals like NaCl, KCl show this type of defect. So when crystal salts of sodium chloride are heated in sodium vapor, what are we doing? Sodium chloride eduthu we will be heating it using sodium vapors. What happens if the surface of the crystal has depositions of sodium ions? So sodium ion path immediately the chloride ion sees sodium ion here. What will happen? The chloride ions will move here. They will go away from their places. And when they go at their positions, they leave electrons in the places from where they are moving. Hope you are understanding. When we are heating sodium chloride in the atmosphere of sodium, sodium gets deposited on the surface. Chloride ion, what it will do? It will move from its place. In its place, it will leave an electron. When these electrons will be occupied in the places where the chloride ion is going, and those centers we call it as F centers. And these centers will give us a color for the compound. Like the chloride ions diffuse to the surface of the crystal and combine with sodium atom to give NaCl. This happens by loss of electron by sodium atom to form Na plus ion. The released electron diffuse into the crystal and occupies the spaces of the anions. Now, because chloride ion is missing and sodium ions are more, it will become excess of sodium ions. See, I said it will occupy the place from which the anion is moving. And these we call it as F centers, and these are the reason why it imparts color. It's a German word, Farben-Center, which means it's a color center. Why does it again give a color? It absorbs light in the visible region, or let me say the light வந்து flameல இருக்கிற temperature போதும் for the excitation of electrons. Excite, de-excite, when it undergoes excitation and de-excitation, மேல போய் கீழ வரும்போது நமக்கு it gives out color in the visible region. So it gives an yellow color to the crystal. So the color imparted in non-stoichiometric defect when there is an excess of metal due to anionic vacancies is because of what is called as the F centers. Same number, lithium chloride, when it is heated in lithium, it gives pink color. Excess of potassium in potassium chloride gives us a lilac color. Lilac is the violet color. Again, this is also equally important to us. There, in the previous case when I was speaking about F centers, அங்க என்ன ஆகுது, நமக்கு anion வந்து மிஸ் ஆகுது. Anion is missing from its point and excess of cations are becoming because of that. Here there is again metal excess defect due to the presence of an extra cation. If we heat zinc oxide, on heating zinc oxide, what happens? Zinc ions are formed. Oxygen வந்து gas formல இருக்கும். So if it is in the form of gas, what happens? Some part of it escapes out. And we have the electron. Zinc oxide is white in color at room temperature. But when we heat it, it turns yellow. Why are we having more zinc ions? Because some part of oxygen escapes out, and when we cool it back, some part of oxygen is lost. So we'll have more of, let me say excess of zinc ions, which will occupy the interstitial sites. Okay. Metal deficiency defect. Like this is generally shown if a metal shows two different oxidation states. Can you tell me what are the, this was the example I took even when I was telling you. What are the different oxidation states of iron? Iron in oxidation state, general cartoon, compounds. What example does it show? Oxidation states in iron. It will be Fe plus 2, Fe plus 3. So it might be possible that some of the iron atoms or ferrous or ferric ions might change their oxidation state. FeO ferrous oxide. So it might be possible that some of the ions might change to ferric ions. So we'll just see how we are getting the composition when we take up a numerical on that. Paakla number or a problem pani paakla, how we are getting this. Okay, let's do with this. The correct statement regarding defects in crystalline solid. Frenkel defects decrease the density of crystalline solids. Is it correct, right or wrong? The Frenkel defect decreases the density of crystalline solids. Arti, is it right or wrong? Frenkel defect is a dislocation defect. Frenkel defect is found in halides of alkaline metals. Schottky defect has no effect on the density of crystalline solids. Frenkel defect நம்ம என்ன டிஃபெக்டா சொல்லிருக்கோம்? Dislocation defect. Dislocation defect there is no change in density. Density will remain same. Frenkel defect is found in what examples we have taken? AgCl, AgBr, zinc sulfide. Schottky defect, missing of the ion. Very good. B option is right. Schottky defect has no effect on density of crystals is again wrong. So the option that is right is Frenkel defect is a dislocation defect. Good. Then let's go for another illustration. The appearance of color in solid alkali metal halides is generally due to interstitial positions, F centers, Schottky defect, Frenkel defect. What is it because of? Fine, because of F centers. Very good. The same structure is given, what we have seen. Fine, let's work on this. The amount of cationic vacancies per mole of a non-stoichiometric iron oxide is 0.14. The formula of the compound is, let's see, 0.14 mole of cationic vacancies implies presence of 0.28 moles of iron 3. Another 0.28 moles because the oxidation state of iron is in +2 state. So let me take X is the amount of Fe +2. (0.28 moles of +3 oxidation state plus X moles of +2 oxidation state will be equal to 1 mole of what? Oxide ion. +3 oxidation state வந்து நம்ம 0.28 moles எடுக்கலாம். And for +2 oxidation state we are taking it as X. So let's solve that. 0.28 into 3 plus 2x is equal to 2. Calculate this. 0.28 into 3 will be equal to 0.84 plus 2x is equal to 2. 2x will be equal to 2 minus 0.84. 2 minus 0.84 எவ்வளவு வருமா? 1.16. 2x is equal to 1.16. X will be 1.16 by 2. What will be 1.16 by 2? 0. Okay, let me write it here. X is equal to 1.16 by 2. It will be equal to 0.58 moles of iron. When I was talking about non-stoichiometric defects, some of the ions will change to a different oxidation state. So non-stoichiometric defects generally எங்க வரும் நமக்கு when a metal shows two different oxidation states. Options வந்து not these options, by mistake these options have come. Once we get this, what we will try to do is we'll just see if we can do further. (0.28 moles of Fe plus 3, 0.58 moles of. See, we stopped at here. The options were given for the complete composition of see what we have got is 0.58 moles of iron plus 2. நமக்கு இங்க already இருக்கிறது என்ன 0.28 moles of iron in plus 3 state. So total iron amount எவ்வளவு இருக்கும் 0.28 plus 0.58 0.86. So நமக்கு எந்த formula வரும் Fe 0.86O. 0.58 வந்து Fe plus 2. Very good Aditi. நமக்கு already என்ன தெரியும் plus 3 oxidation state வந்து 0.28. So total எவ்வளவு வரும் நமக்கு 0.28 plus 0.58 வந்து 0.86. Okay, the answer is Fe 0.86O. So just that's complete theoretical. Generally they ask you in the defects textbook நல்லா படிங்க. Electrical and magnetic properties again is the theoretical part of it. Depending on whether a substance conducts or does not conduct, we classify them into conductors, insulators and semiconductors. When do we say a substance as conducting? When it can allow the electricity to pass through it. They allow the maximum portion of applied electric field to flow through them, and the conductivity value will lie between 10 power 6 to 10 power 8 ohm inverse. If any substance has its conductivity value within the range of 10 power 6 to 10 power 8, we call them as conductors. And metals are examples of conductors. They conduct due to flow of electrons. Insulators, those are the substances which will resist the flow of electrons or which will not allow the electricity to pass through them. We call them as insulators. For insulators, the electrical conductivity is very, very less. 10 power minus 10 to 10 power minus 20 ohm inverse, meter inverse. So if the conductivity, it's almost negligible value. If you can see, the negative power makes it ரொம்ப கம்மியா இருக்கும். என்ன conductivity value வந்து ரொம்ப கம்மி. See, இங்க பாருங்க minus 10, minus 20 இருக்கு. அதே semiconductors எடுத்தா நமக்கு metal conductors and insulators நடுவுல இருக்கும். The solids with intermediate conductivity at room temperature, semiconductors allow a portion of electric current to flow through them. So conductivity in solids எப்படி இருக்குமா? Due to movement of electrons. See how the electrons, or let me say, they are moving. Are you able to see? It's almost like the sand particles moving. It's moving from the remaining part of atom without the valence electron. We call it as kernel. What is a kernel? Without the valence electron, whatever part is left, we call it as a kernel. So one atom, it moves from one atom to the other atom, gets attracted. Now, for a substance which conducts, we have the valence orbits which have completely valence orbits with the electrons. We call it as a filled band. Above that, we have an empty orbital which we call it as the empty band. In the conduction, whenever we take the conduction, number valence orbitals electrons irkumo, we will call it as a filled band or a valence band. Unoccupied orbital without an electrons வந்து நம்ம conduction band சொல்லுவோம். Conductorsல இந்த valence bandக்கும் conduction band நடுவுல place இருக்காது. Almost like overlapping. What is why, ma? Was your doubt, Maithili? Okay. What are these partially filled? These are your valence orbitals. So, நம்ம metalல ஏதாவது which is a conductor, the gap between the conduction band and the filled band வந்து இருக்கவே இருக்காது. So, it can easily the electrons can move from here to here. அதே semiconductors பார்த்தா the difference வந்து கொஞ்சம் கம்மியா இருக்கும். It can move from this band to this band either by heating or adding impurity. We can increase its conductivity either by adding an impurity or heating it. அதே நம்ம insulator பார்த்தா the distance is so much that any of these things cannot help us to be conduct. So நமக்கு insulatorsல என்ன இருக்கும், the filled bandum conduction band நடுவுல distance வந்து ரொம்ப நிறைய இருக்கும். heat பண்ணாலும் நம்ம ஒண்ணும் பண்ணலாம். And even if we add impurity add பண்ணாலும் இந்த distance வந்து ரொம்ப ஜாஸ்தியா இருக்கனால it will not conduct. So if we add in semiconductors la நான் என்ன சொன்னேன், heat பண்ணாலும் it's okay. Maitri, it's okay. In case of semiconductors, heat பண்ணாலும் நம்ம conductivity increase பண்ணலாம், இல்ல ஏதாவது impurity add பண்ணாலும் we can increase. So pure substances that are semiconductors are known as intrinsic semiconductors. If we add some impurity, அது என்ன சொல்லுவோம், doping. Doping என்ன ஏதாவது extra element add பண்ணா, generally silicon and germanium வந்து நம்ம 14th group or we'll call the 4th A group elements. So when we add to them either the 13th group elements, boron, aluminium, gallium, illa phosphorus, arsenic, antimony, 15th group illa 13th group elements add panna, either less valent groups or a higher valent groups if we add, we call it as doping, and we call such conductors as an extrinsic conductors, semiconductors. Semiconductors la நம்ம ஏதாவது impurity add பண்ணாம அது conduct பண்ணா we call it as an intrinsic conductor. இல்ல நம்ம ஏதாவது impurity add பண்ணா we call it as doping, and those conductors we call it as an extrinsic conductors. Doping we are adding to increase the conductivity. இது வந்து without adding anything. Here we are adding arsenic. Arsenic வந்து 15th group. So 15th groupல எவ்வளவு electrons இருக்கும்? 5 electrons இருக்கும். Silicon germaniumல நமக்கு 4 electrons இருக்கு. Arsenic வந்து 5 electrons. So என்ன ஆகும்? 4 electrons will form bonding and one extra 5th electron will be present. So this electron will move. இந்த electron வந்து நமக்கு move ஆகும். It moves from one atom to the other atom. And here the conductivity is because of the negative charge, so we call it as an N-type conductor. இங்க வந்து நம்ம என்ன add பண்ணோம், 13th group. 13th group elements add பண்ண என்ன ஆகும், 1 electron வந்து கம்மியா இருக்கும். கம்மியான when compared to what? When compared to the silicon or germanium. Silicon germaniumல எவ்வளவு electrons இருக்கு? நம்ம 4 electrons இருக்கு. Out of the 4 electrons, 3 electrons are forming bonding. I mean only 3 electrons can form bond because there is only 3 electrons in boron. So என்ன ஆகும், இங்க நமக்கு space வரும். Sorry. We'll have a space in between. So we call it as a hole, positive hole. So இது வந்து when it is moving from one atom to the other atom, in the positive hole will move this side, electrons will move in the opposite direction. So நமக்கு p-type semiconductor எப்போ சொல்வோம், when we are adding a less valent element into the 14th group வந்து நம்ம p-type semiconductors சொல்வோம். அதே if we add a higher valence element, நம்ம வந்து அது 15th group add பண்ணா, 14th groupல நம்ம 15th group element add பண்ணா, dope பண்ணா, we will call it as an N-type semiconductor. So N-type, you remember negative charge and the conductivity is because of electrons. In P-type positive charge, you remember that way, positive holes. Holes are empty space. எதனால empty space வருது நமக்கு? Because the number of electrons of boron is less than that of silicon and germanium. Valence electrons la difference irukku. So let's take about the magnetism. Is it clear till now? I'm going with the last part of solid state. Yes, magnetism. We know that when electron is moving around the nucleus, it orbits in its position. Electron orbital motion and spin are the causes of magnetism in this. When chemical bonding magnetic moment, there we have taken between the charges, difference in the charge separation. We call it as dipole moment there. Here we are talking about an electron. When it is moving around the nucleus, it will create a magnetic moment. So when electron is spinning, either in the clockwise or the anti-clockwise, what happens? The magnetic moment that is created will be almost perpendicular to it. On the basis of their magnetic properties, substances are classified into paramagnetic, ferro, anti-ferro and ferri. Paramagnetic, diamagnetic we have seen in chemical bonding also. Chemical bonding molecular orbital theory isn't it? Molecular orbital theory explains about the magnetic property. Paramagnetic substance enna solvoma anga enna sonna those which gets attracted feebly towards the magnetic field. External magnet, if you bring it near, enna agum koncham magnetic effect nala it gets attracted, and that was because of the presence of unpaired electrons. Diamagnetic no unpaired electrons, no attraction. இங்க நம்ம கிளாஸிஃபை பண்றது மேக்னெட்டிக் மொமெண்டோட வச்சு கிளாஸிஃபை பண்ணுவோம். Diamagnetic are weakly repelled by the external, or let me say they don't get attracted, and these will have no unpaired electrons. Titanium oxide, sodium chloride, example benzene edukkalam. These are all diamagnetic substances. Paramagnetic, which are weakly attracted by the magnetic field, are called paramagnetic. They have permanent magnetic dipoles due to the presence of unpaired electrons. The paramagnetic substances lose their magnetic nature. External magnet eduthuta it will lose its magnetic field. Magnetic nature if it still retains its magnetic property even after an external magnet is removed, then we call it as a ferromagnetic substance. Examples you will have to learn whatever is there in the textbook. Ferromagnetic substance show permanent magnetism even in the absence of magnetic field, are called as ferromagnetic. Number iron, simple example, it has a magnetic property. Nickel, carbon monoxide, CrO2. In the example easy number, iron and nickel, because we use it. They are also used for making permanent magnets. Antiferromagnetic substances are enna. If you look at their electronic configuration, they based on their electrons, we feel நம்ம என்ன நினைக்கலாம்னா magnetic property இருக்கும். Paramagnetic property ஆக இருக்கலாம், ferromagnetic property ஆக இருக்கலாம், due to the presence of unpaired electron. But அது magnetic moment ஜீரோவா இருந்து it is not having any magnetic property. அது நம்ம என்ன சொல்வோம், anti ferromagnetic substances. We feel that there is some magnetic property to it, but it does not have a magnetic property. நம்ம என்ன சொல்வோம், anti ferromagnetic substances. Example MnO, Mn2O3, MnO2. Manganese oxides. Last நம்ம என்ன இருக்கு, ferrimagnetic substances. இது again we feel that magnetic property வந்து ரொம்ப ஜாஸ்தியா இருக்கும் நினைக்கலாம். ஆனா கொஞ்சம் இருக்கும். இங்க வந்து நமக்கு சுத்தமா இருக்காது. ஆன்டி ஃபெரோ மேக்னெட்டிக் சப்ஸ்டன்ஸ்ல சுத்தமா இருக்காது. இங்க வந்து கொஞ்சம் இருக்கும். Small net magnetic moment are called as ferrimagnetic substances. நம்ம என்னென்ன பார்த்தோம்? paramagnetic, diamagnetic, ferromagnetic, anti-ferro and ferri. ஜாஸ்தியா இருக்கிறது ஃபெரோ, பெரிமேக்னெட்டிக்ல கொஞ்சம் கம்மியா இருக்கும், பெராமேக்னெட்லயே இருக்கும், டயாமேக்னெட்டிக் சுத்தமா இருக்காது. ஆன்டி ஃபெரோல என்ன ஆகும்? we feel that there is magnetic property but we don't find any magnetic property. So this is how you can see the arrangement and then understand. In ferromagnetic நம்ம magnetic moments வந்து எல்லா because of different electrons all the magnetic moments are in same direction. So அதனால என்ன ஆகும்? The magnetic property will be more. Antiferrol என்ன ஆகும்? Equal number of opposite ones. 1, 2, 3 இங்கேயும் 3 இருக்கு. So though there are magnetic moments equal and opposite, I mean equal number of opposite movements will make it 0. Perimagneticல எப்படி இருக்கும்? At least 1 or 2 will be left, not equal number of opposite ones. You have 1, 2, 3, 4 வந்து நமக்கு இந்த சைடுல இருக்கு. 1, 2, 3, 4, 2 வந்து opposite sideல இருக்கு. எவ்வளவு ரெஸ்ட் இருக்கும்? 2 கேன்சல் ஆயிட்டா நம்மளுக்கு இருக்காது இன்னும் 2. இங்க வந்து எல்லாமே ஒரே சைடுல இருக்கு. என்ன இருக்குமா? மேக்னெட்டிக் மூமெண்ட்ஸ். The magnetic behavior showed by the electrons directionல நம்ம பார்க்கலாம். என்ன டைரக்ஷன்ல இருக்கு? இது எல்லாமே ஒரே டைரக்ஷன்ல இருக்கிறதுனால இதுக்கு வந்து ரொம்ப ஜாஸ்தியா இருக்கும் மேக்னெட்டிக் ப்ராப்பர்ட்டி. இதுக்கு வந்து கொஞ்சமா இருக்கும், இது சுத்தமா இருக்காது. எதுக்கு சுத்தமா இருக்காது? ஆன்டி ஃபெரோ மேக்னெட்டிக் சப்ஸ்டன்ஸ்க்கு வந்து சுத்தமா இருக்காது. ஓகே, இது பார்க்கலாம். ஆன் டோப்பிங் germanium. On doping germanium metal with an indium or gallium. Indium or gallium என்ன group வரும்? 13. Boron, aluminium, gallium, indium, thallium வந்து நம்ம 13th group. So 13th group silicon germanium நம்மளுக்கு எந்த groupல வரும்? 14th group. Carbon, silicon, germanium, tin and lead வந்து நமக்கு 14th group or the 4th group. So இந்த 4th groupல 3rd group element add பண்ணா என்ன type of semiconductor வரும்? P type or N type? Is it P type or N type that we get? எது வருமா? Is it P or N type? We'll have less number of electrons, so we'll get a P type semiconductor. Fine. Number we whatever examples that were given, we are trying to do it. Benzene வந்து நம்ம எங்க பார்த்திருக்கோம்? Diamagnetic. Benzene வந்து நமக்கு diamagnetic substance. CrO2 வந்து ferromagnetic. Just learn the examples. Examples ஏதாவது நம்ம bookல இருக்கா அத படிச்சா நமக்கு this is easier one. Ferric ion is paramagnetic with 5 unpaired electrons. எப்படி வரும் நமக்கு? If you take iron, it's argon, 3d6 4s2 வந்து electronic configuration. Plus 3 ல இந்த 2 electrons இது ஒரு electron, we will have to take it up. So argon 3d5 4s0. எல்லா 5 electrons unpaired இருக்கும். So Fe plus 3 is paramagnetic with 5 unpaired electrons. So எங்க இருக்கு Fe plus paramagnetic? This is 4th. Benzene is diamagnetic. So 1, 5 வந்து நமக்கு 3 options இருக்கு. So 1 was 5, 2 is 3, 1 is 5, 2 is 3. Again we have all the 3 options A, C. So B eliminate பண்ணலாம். A, C and D வந்து 1, 5, 2, 3 இருக்கு. Third வந்து manganese oxide. What is it? Antiferromagnetic. So this we can eliminate now. We'll go for these two options. C option is right. Good. Fine. This will complete your solid state. Give a reading. Solve the problems. Very basic chapter. Second year la romba basic chapter and very basic questions are asked on this chapter. Fine. Let's wind up the class. Practice questions from the book. Solve everything from the textbook. There are questions directly asked from the textbook. Direct textbook NEET students complete textbook solved and unsolved examples try பண்ணுங்க. Any doubt you ask me in the next class. Thank you. Bye ma.